Okay, hello everybody. In this lesson I'm going to talk about polyatomic ionic compounds. So these are ionic compounds that have polyatomic ions in them. So hopefully at this point you've got your polyatomic ions memorized because you're going to start using them a lot in this section. So for polyatomic ions, what we're going to look at, actually before we do that I just want to mention one thing, which is about lead and tin. When we talk about multiple charges, by the way, for ions, on the periodic table, we talked about the transition metals, and most of the transition metals have those multiple charged ions. There's two other exceptions, which would be our lead and our tin. Okay, so the lead and the tin actually they're not inside the transition metals. So there's a problem. Oh, hold on, back it up. Okay, transition metals tend to have those multiple charges. Elements not in the transition, no multiple charges. So these will never have stock numbers. These will always be the same charge. There's multiple charges. Now the exception to that is silver, zinc, and cadmium. They are in the transition metals, but they do not require stock numbers. So if on your periodic tables that you have, I would make note of these three so you don't forget. So as you're doing practice problems and homework problems, you keep reminding yourself. Tin and lead are going to fall into that same category, but the opposite. Okay, here they're not transition metals, but they do require stock numbers. Tin and lead actually have to have stock numbers because they're, well, I don't want to get into the why right now. We'll explain the why later, but you just kind of have to know that lead is Pb 2+, or lead can be 4+. Okay, we'll explain the why later, and you don't have to memorize these again. I'll show you in examples with the polyatomic ions how I can derive these charges. Tin can be 2+, or it can be 4+. Remember we were numbering these things over here with the periodic table. We put an X here because it could be 3+, then 4+. Well, these will be 4+. Okay, and there's a reason why they'll be 2+2 as well, and I'll explain that when we get to electron configurations. But for now, there is another group that requires stock numbers, which would be tin and lead. Okay, back to polyatomic ion naming. So if you have the basic naming system down for binary, this is not going to be any more difficult. It really isn't, unless you didn't memorize your polyatomic ions. If you didn't memorize polyatomic ions, things can get a little tricky. So let's take a look at a few examples here. Let's say that we're looking at I thought I had something here. SrOH. Here's the formula. What I want you to do is to give me the name. So all we do is we name this Sr, which hopefully you know is strontium. Right? We name our cation, and then we name our anion. Now, the problem is there's more than two elements in our formula. That right away should give you a clue that we have a polyatomic ion in here. So because you memorize these, you're going to start to recognize OH in your group. And hopefully remember that OH is called hydroxide. Remember, leave a little bit of a space between the elements so that you can put a Roman numeral if you need it. Strontium hydroxide. I name my cation and my anion. My cation is strontium 2+. My anion is OH-. This whole thing gets that minus charge, so we keep it as a group. Okay, and that's why we have the 2 down here. We don't write that as SrO2H2. It's too hard for people to recognize the OH. You want to be able to see this immediately as you see the formula. So again, if you didn't memorize those polyatomic ions, you're going to have a lot of trouble with this. So strontium hydroxide. Now, one last thing I need to do before I finish is check for strontium. Is it a transition metal? Strontium is right over here. It is not a transition metal, so therefore I do not need a stock number. Remember, the exceptions would be tin and lead. Tin and lead do require stock numbers. Strontium is not a transition metal, and it's not tin and lead, so therefore no stock number is needed. So therefore, there's my name, strontium hydroxide. Let's take a look at another one. Say we have AlNO3 parentheses 3. Name my cation, aluminum. Okay. Then I look at my anion. My anion is NO3, so therefore NO3 is a trait. So therefore I check again, look at my periodic table. Do I have aluminum? Is it a transition metal? Technically it's not. Transition metals end right here. There's a break here, so that is not a transition metal. Aluminum has a 3+ charge. Technically the only metal you're going to really see that has that charge like that, a 3+ charge. Okay, so therefore aluminum does not require a stock number. No stock number needed. Alright, let's try another one. Let's say I have copper, carbonate. Really, see, the rules aren't really any different. It's just a matter of remembering the what's my fault? I was too busy thinking. Let's try it again. CuCO3. So it's the same thing I did before. The only difference is I'm substituting in polyatomic ions here. So again, name a cation, copper, leave a space, carbonate. How do I know carbonate? Because I memorized my polyatomic ions. And then I look for copper. Now where is copper on the periodic table? It's right here. It will require a stock number, so we have to go back and figure out what the stock number is. So you should have memorized CO3 along with its charge, because it's CO3 2-. Okay? So if I have copper, and I only have one of them, right? There's only one copper here. The 3 doesn't mean that I have 3 carbonates. It means that the carbonate has 3 oxygens within its structure. This is the polyatomic ion. So therefore, if I have one carbonate and one copper, it must have a charge of 2+. So I have to have a stock number because it's a transition metal, and the stock number needs to be a 2. So copper 2 carbonate is the name of this compound. Now, don't get it confused with copper 1 carbonate. This one over here is going to be copper 1. Why copper 1? COPPER parentheses 1 carbonate. Because it tells us the charge on the ion. It doesn't tell us how many. So therefore my carbonate is 2-. The coppers, I have 2 of them. Remember, that's what the number down here tells me. It tells me how many I have. So therefore each one of those has to have a +1 charge, and that is what the stock number tells us. It tells us the charge on the ion, not the number of ions. So very, very tricky for students. Okay, one more this way, and then I'm going to show you the other way, going from the name to the formula. Alright, so let's say I have SN. Oh, you know what? No, I think we're good. I'm going to actually go back the other way. Let's take a look at giving you the name and you writing the formulas. So let's say that the formula is, let's go with something relatively easy first. Let's say it's, ammonium bromide. Okay, so I do just like I did with the binary ones. I just write the formula, NH4, remember I have to have that memorized, should have a +1 charge. Bromide is Br. If you forget this one, you can always look it up on the periodic table. Bromide is here, -1 charge. So therefore, -1. And if I put those together, +1, -1, I end up with ammonium bromide. That's it. Now, the question is, do I need parentheses around that ammonium? Technically, no. Some students like to write NH4 parentheses bromide. I guess you could do that if you wanted, but typically we only put the parentheses if there's more than one of those polyatomic ions. For example, if I have something like ammonium, and let's say we do ammonium sulfide. Again, it's going to be NH4 plus S2-, right? Because ammonium and sulfide. So this time I'm going to need 2 of these ammoniums, right? Because I have to balance out, I have to put in 2 of the whole thing. Double those polyatomic ions. So therefore now I'm going to have NH4, but I have to indicate that I have 2 of them. So that's why I put parentheses here and a 2 and an S. Ammonium sulfide. And that would be my final formula for this. And here I have to use parentheses. I can't just make that, and do not write this. Don't write 2H8S, because it's too hard. I don't recognize it as ammonium. We all have memorized NH4 as ammonium, so NH2H8, or sorry, N2H8 is not ammonium. That's confusing, so stay away from that. Okay. All right, one last one, and I'm going to end it here. This is going to be a tricky one because it's going to have the lead in it. So let's say we have lead. Oops, am I writing that the wrong way? Let's write the word lead. Lead. And let's go with lead 4 oxide. This is the one that a lot of students miss, so be careful and pay attention here, okay? All right, so lead is Pb4+. Oxygen is 2. Oh, this isn't even a polyatomic ion. Oh well, that's okay. All right, so if you want to throw a polyatomic ion, I'll do one more if you want. All right, so lead 4, oxygen 2. So we're going to balance these two together. And a lot of students do, a lot of you are using, is this switching of the ions, right? You just take this, put it down here, and you take this, and you put it down here, which is fine, but this is not the right formula. Ionic compounds, because we're balancing charges, must always be in lowest ratio. So therefore, you just have to remember, if you write it like this, to reduce it down to lead with a 2. Question is why? Because if I have lead 4+ and oxygen 2-, I only need one more oxygen to balance it, don't I? Right? I don't need to have that extra oxygen and the extra, leads in there. I just need 2 oxygens and a single lead, and that's what our ionic formulas always represent. Okay? And that one is one of the trickier ones for students. And it gets even trickier if you do something like do tin, and we say tin 4, and we do something like sulfate. Throw a polyatomic ion in here. This is like the primo problem here. Alright, so I would do tin 4+, sulfate, which would be SO4, 2-. Okay, so again, if I did this and I switched those charges, students tend to get tin with a sulfate, and I would have a 4 here. Notice that I put parentheses because I'm putting this down at the bottom for both of these, right? You got to keep that in mind. This is acting as a group. Don't break that down. I personally would rather do it a different way, and I'll show you in a second. SO4 with a 2. Okay, shortcut works, but you got to remember to reduce it down to its lowest terms possible. What I would do for this is just notice the charges: 4+, 2-. I only need a second SO4 2- to balance that, don't I? I have 1, 2, so my formula would be SN, and I need 2 sulfates, SO4s. Okay? So that's it. That is all the rules for writing ionic compound, from binary with single charge that are not changing. Those are your alkali metals, which we saw on the periodic table. So those are your alkali metals. Those are the ones that don't, in alkaline earth metals and aluminums, zinc, cadmium, silver. No stock numbers are needed. Okay. Then we get the transition metals, which do require stock numbers. So we have those binary compounds, 2 types: fixed charges, multiple charges. Don't forget about tin and lead. Then we move into the polyatomic ions. Same rules, same things apply, but you just have to have those polyatomic ions memorized. Okay, so I hope that helps, and we'll finish wrapping up all the ionic compound stuff in class, and we'll move on to acids and molecules. And those naming systems are by far a lot more simple and more streamlined. Thanks a lot.